So this is the third problem in the probability review for the final exam. So we're looking at people with O negative blood type. They're called universal donors because any patient can receive a transfusion of O negative blood. Now we have the probabilities or the percentages. 7.2% of the American population is O negative. So first, as in any other probability problem, write down your probabilities as an equation. So P of, which means probability of O negative is or is equal to 7.2% is so 7.2% is 7.2 over 100. Shift the decimal point one place to the left for every zero in the denominator, so that would be 0.072. The opposite of that event that someone is O negative is not O negative. So the probability that someone is not O negative, that's the negation of the event that someone is O negative, is 1 minus 0.072, which is 0.928. So the first question is, 10 people appear at random to donate blood. What is the probability that none of them is a universal donor? So if there are 10 people, the first, none of them are, so the first is not, and the important word between these two is and. The second is not, and the third is not, and we keep going until we reach the 10th. So the word and goes with multiplication, goes with the multiplication rule. Now the events here are independent of each other because they're different people walking in randomly. So one event is independent of the other. So for independent events, all you have to do is multiply the probabilities. So you have 0.928 not O negative, and so times not O negative 0.928 and 0.928 not negative. So every time I say and, I multiply, and they're independent events. So all I do is multiply the probabilities. So now we have 10 of these multiplied repeatedly. So that's where the 0.928 to the 10th power comes from. Enter it all into your calculator. So it's 0.928, 0.928 to the 10th power. Enter that into your calculator to get 0.4736. Now in part A, we figured out the probability that all 10 people that walk in to donate blood, none of them is a universal donor. None, which means the first is not, and the second is not, and the third is not, and so on. Now the next question says, if 10 people appear at random to give blood, what is the probability that at least one of them is a universal donor? Now, when we say at least one of them is a universal donor, the list is long. So out of the 10 people, the first could be a universal donor and the rest are not. Or the second could be a universal donor and the rest are not. Or the third, and the list goes on. And then we have to consider, what if 2 people are universal donors and the rest are not? And then there's another long list of possibilities, and then 3, and then 4. So it is not impossible, but it is unnecessary to list all the possibilities. It's a long, long list of possibilities. The minute you're running a long, long list of possibilities in your head to answer a question, you have to think about an easier way of doing things. And let's look at an easy way of solving this problem. So what we need to figure out is probability of at least one universal donor in 10. Remember that it's not just one, we have 10 donors. So we think about the complement of the event or the opposite event to at least one universal donor in 10. So the probability that there is at least one universal donor in 10 is equal to 1 minus the opposite event, or the negation of this event. So the way you figure out the negation of the event, if it's confusing to think through this, then all you have to do is replace at least one. So replace at least one by none, and then you've got the opposite event. Leave everything as it is, but replace at least one by none, and that makes it the opposite event. And then think through what exactly that means. So we have 1 minus probability of the opposite event equals 1 minus probability of the event that we're replacing at least one by none. So no or none universal donors in 10. So that is equal to all non-universal donors, which means non-O negative blood types, which we've already figured out. All 10 are not O negative. Each one of them is not O negative. So we figured that probability out here. We don't have to redo that. So we take the answer from the previous section and plug it in here, and we get 0.524 as the answer.